Now let me tell you the next thing that we will do here, the surjectiveness of a function. Okay.
Okay.
Yeah, surjective. Because so why we are defining this, I'll tell you. You know, most of the time in the case of counting, we just using the concept of function. So if I give you some collection of ball and asked put the numbering on the ball, then it is nothing but a bijective map from the set of natural number, so some partition of natural number, to the collection of ball, right?
Okay.
That's why here we are doing more general, but the motivation comes from there, the counting process. Okay.
Okay.
Counting mean what? One, two, three. So if I give you a collection of ball, yes, then what? How you count those collection of ball? So let's say you have a collection of ball here, 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 here. Maybe
Mm.
this, yes. So then I asked count them and number. So this means you are putting a numbering, right? Basically, yeah. You have one, two, three, four, five, six. I don't know how many needed. So one you take
Mm.
this in the place two you put this, yes. In the place three you put this, and in the place four you put this, five you put this, in the place six you put this, and in the place seven you put this. So this is nothing but
Mm.
a map, right?
Yeah.
Right. So in general, so if here if you have a infinite set, then so the target to count the number of element inside a infinite set, that is little bit difficult in mathematics or in counting process. Okay.
Yeah.
So that we can capture by logic, that is basically the bijective map. Okay.
Okay.
All right. So come to here. So let me explain the surjective. Then I go to the bijectiveness. Okay. So
Okay.
yeah. Okay. So what is surjectiveness? So this means, say, suppose you know I give you a collection of balls. You have collection of some balls, and I asked count them. So this means you are putting a number one, two, three, four on the surface area of the ball, right?
Yeah.
So if by mistake you not write a number on one ball on the surface of I mean on the surface, then what happened with that ball? You miss that ball right here basically.
Yeah.
So this means, yes, for this ball you have no pre-image. So in the counting process you are writing one, two, three, four, but in mathematics they will give you a formula for fx equal to some expression, and then they asked,
Mm.
yes, is this formula hitted all the point of the second set? So if it hit at all the point of the second set, you say it is surjective. If one mistake, at least one mistake, I mean, you have no, pre-image for one element from the second set inside the first set, then you say it is not surjective. Okay,
Okay.
right. Okay. So a function f a to b, so a b are given. Now a map f a to b is called. Sometime people call them onto also. So
Okay.
yeah, surjective if for each element b belongs to b, there exists at least one element a in a such that f of a equals to b. Is it okay?
Yeah.
Right. So let me explain with two examples. So one example, the map will not surjective, and for other, the map will be surjective. So here example. So let me tell you, by diagram. So one, two, three. So finite set I am taking, and A, B, C, D. So let me give you a map. 1 goes to A, 2 goes to 1, 3 goes to C. Is it a surjective map?
No.
No, because B and D, I mean, B has no pre-image. Also D there is which has no pre-image. So this is not surjective,
Okay.
right? But if you have finite set and you have a diagram, it is easy to check surjectiveness because everything you can see in front of you, right? But infinite set, if
Yeah.
you have, yes, and there is a formula, so you have to be strong with the formula, right?
Mm.
So that is challenging for you. I don't know how much you are comfortable with the function. Depend upon on it. You can check immediately the function surjective or not. Okay. So
Okay.
let me define a function f. N to n, natural number to natural number, by fx equal to 2x. Is this a surjective function?
Mm, not sure.
So x goes to 2x. Okay, natural number means, so basically you have a map from 1, 2, 3, dot 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 to 1, 2, 3, dot 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 dot. Defining this way. 1 goes to 2, 2 goes to 4, 3 goes to 6, this way.
Mm.
So, so is it a surjective map from n to n?
Yes.
No, no, no. Carefully look. So n to n, n to n, n to n.
Oh, because it's not going to hit
It,
every single natural number,
yes, 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 yes,
so
yes,
it's not
yes,
adjustable.
yes, yes. Which number
Okay.
are not heated? The odd number.
The odd numbers, yeah. Okay.
Yes. So, for example, 1. If you take here 1, that has no pre-image in the set this, right?
Mm-hmm.
That's the problem. Yes. Now,
Oh,
yeah, got it?
yeah.
Very good, very good. But it is a injective function, right? Not
It
surjective.
is injective, yeah.
Yes. Because here, if you take two distinct element, they map to two distinct element, right?
Yeah.
But injective. So this map is not surjective, but it is injective from end to end. Did you understand the concept? How you check? So
Yeah.
yeah. Here I explain for finite set using diagram. Here by formula. See, the problem, you have to understand the formula very nice way. If you understand the formula
Mm.
nice way, yes, and then you can easily check. Okay, that is surjective, that is injective. Okay, and we have
Okay.
yeah strong process how to check the injectiveness, right?
Mm.
So just I told you right how to check injective for f of x1 equal to consider f of x2. Then what do we get here? 2x1 equal to 2x2. So then we get immediately x1 equal to x2. So therefore it is injective, right?
Okay. Yeah.
Right. But do we have any process to check surjectiveness? Yes, there is. How? So
Okay.
you start any element from here. So you take 2x equal to y. Okay, then solve for x. Okay.
Okay.
So yeah, because you know what? What is our target? Our target, if we take any element y here, we will find x. That we need, right? Finding, right?
Yeah.
Such that this x will map to y. So this means we start with the equation fx equal to y. So this means 2x equal to y. So x will be what? Y divided by 2, right?
Yeah.
Oh, I have, I need a yes. So x equal to y divided by 2. Now this x, I mean y divided by 2, need to belongs in the set A, right? For all y. But it is not possible. It is only possible if y you take event, right?
Mm.
Fine. Any question so far?
No, it's
Very
clear.
good. Very good. So let me tell you next. It's called bijective map. Okay. Yeah. So any map, you know, which is injective and also bijective, I mean surjective, then we called it is a bijective map. Okay.
Okay.
A to B, yes, it's called bijective.
Sir, maybe we can do this one and then do just introduction to the composition of the first, so I know the like, because I did not study the composition.
Yeah.
So if we can do just like after the bijection, we can do a little composition, just introduction to the concept, and then we start with the questions, if that's fine.
Oh, yeah, yes, sure. So composition, I will tell you. Then
Okay.
yes, we will start the yes question. Yeah, exactly.
But I need now. What time is it for you? It's 2 hours difference, I think. It's
10,
11 now there.
no, no, 10:30.
1 hour and a half. Okay, 10:30. So what time do you like sleep or like finish?
Oh, so the class you want to finish? How long time I took?
Because I have time, but I need to go to university, and that takes 1 hour. So like if you are going to sleep early, then tomorrow morning we will continue.
Yeah, morning mean my six will work. My 6, 7 like that.
You're 6, 7. Okay, that's fine.
That works. Yes. So I think let me finish the concept today. Then we start from tomorrow
Yeah.
that question like that. Okay.
Okay.
Fine.
Yeah. Good.
Very good. Okay. So if A to B is called bijective, if it is both, if it is both injective and surjective. Okay. So now see, let me tell you little bit. What is the profit? If your map is bijective, this means you have here set, you have here another set. So this is set A, this is set B. So injective make you the guarantee that distinct element map to the distinct position, right?
Yeah.
And surjective allow you to guarantee that if you take any element, you have a pre-image here. So like that. So the elements of A and elements of B are one to one correspondence, right? Right.
Yeah. Yeah.
Okay.
Understood.
Yes. So bijective map, is very important because you can compare the elements of A with the elements of B. Fine.
Fine. Okay.
Okay, good. Right. So now let me tell you the next idea is the composition of map. Okay.
So I have a question about bijective. So if I want to check bijectivity, I just check injectivity and surjectivity, and
Yes.
if both, then it's
Bijective.
automatically bijective.
Exactly. 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 Yes. Okay. Fine. So let me tell you a question. Bijectiveness. Let me check. R to R is given by fx equal to 7x plus 9. So is this map bijective? We check. Okay.
Okay.
Yeah. Is f bijective? We check this. Right. So can you check this?
Okay,
First
I'll
check in
try.
it. Yeah. Right, please. Tell me I am writing here. So then it will take less time. So first
Okay,
injectivity.
so I'm doing f of x1 is f of x2.
Very good. Then what we get?
Okay, then I'm solving. It will become
What is f of x1?
7x1 plus 9.
Yes. Equal to then what should we get? 7.
7x2 plus 9.
Okay. Then,
We can cancel the 9
yes,
and the 7 also after.
yes. So injective.
So it will be,
So yeah, so this is injective, no doubt. Yeah, okay. So now let me check the surjectivity.
so I'll do 7x plus 9 equals to y.
7x. So how we do this? We start with a element from the codomain, right?
Yeah,
Let y belong to R. You can write down here from the codomain. So the second set we call codomain. Okay. So we find x, right?
yeah,
How you do this? So now fx equal to y. You start with this and solve for x. So what is this? 7x plus 9 equal to y. So then what we
yeah.
get? 7x. Yeah, tell me.
X equals to y minus 9 over 7.
X equal to y minus 9 over 7. Now check, is it a real number?
Mm,
Yes. Y is a real number.
yes,
9 is a real number. Divided by 7 is a real number. Which is a real number? So it is inside
yes.
the domain. Yes. So pre-image of y is y minus 9 by 7. So this means if you take here y, which element map to y? Y minus 9 divided by 7 by the rule f. Fine.
Yeah,
So this map is a injective, I mean both injective and
yeah,
surjective, so it
bijective.
is a bijective. Exactly. Exactly. Fine. Okay. So should I give you a little bit difficult question?
Okay, we'll try.
Okay. Okay. So here it is. Sorry. One second. So actually I'm living nearby so train so
Oh,
something.
it's okay.
Okay. Are you from actually originally from India or are
No, I'm
okay.
half Indian,
Okay.
half
Okay.
Arab.
Okay.
So
Okay, got it. Right. So let me write down here. So here the question. F add to R by so okay. Okay, just let me tell you the formula. You calculate the domain. Okay.
okay,
So A to B by so by where A B subset of R fx equal to x plus 3 divided by x minus 2. First question. Find domain domain of this F map. Okay.
okay,
First we calculate the domain of this map. Yes.
okay. So it's greater than or no, it's greater than 2.
Greater
X is
than 2.
greater than
Greater than no, not greater than 2. Check little bit carefully. Which number you cannot put in the place of x?
2.
2. Only 2. Yes. So what is the domain? So domain of f is so alright. So domain of f is all real number x except 2 like that. Okay.
Okay,
So this means we can write down. So if you look at the real line, we only we take all number except 2. So this means negative infinity up to 2, 2 not allowed, so bracket, parenthesis, and then union 2 to infinity, like that. You can also write down. Okay.
okay,
I think you know this notation, right? Union.
yeah.
Okay, fine. So domain is this. Now, is this a injective? So injective. So is
Yeah.
F injective? Yes. Check it
Okay.
on its domain. Yeah, please.
minus 2.
So start the
Um,
f of x1 equal to f
okay,
of x2. Yeah.
yeah, so I'll do x1 plus 3 divided by x1 minus 2 is equal to x2 plus 3 over x2 minus 2.
Uh-huh. Simplify.
Yeah,
So x1 plus 3 into x2 minus cross multiplication you can apply.
yeah, I'm
So what
doing
should we get?
minus
I am doing
2.
also here calculation. Just check with me. So x1 x2 minus 2x1. Yes, sir.
2 minus x1 3.
Yes. Yeah. Can you see?
Yeah, I'm doing the same as you now.
Okay, please.
Minus 2x1. Okay, I can cancel the 6 from here, the minus 6.
Yes. What did you get in the left hand side? Did you get x1 x2 minus 2x1 plus 3x2 minus 6?
Hello?
Yeah, yeah. Left hand side. Hello. Can you hear me? Hello. Hello, hello. Yeah. Sorry, 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 sorry. My mic was mute actually. Can you hear me now?
That's okay.
Okay. So, have, what did you get in the left hand side? Can you tell me left hand side?
Yeah, I can cancel the x1, x2 from
Yes.
both sides, and
Very
then
good. Then negative 6, negative 6. Did you get x1 equal to x2?
yeah, just 1 second.
Mm-hmm.
Yeah, x1 is equal to x2.
Very good. So it is injective, right?
It is,
Nice. Okay. 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 Good. 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 Now tell me one thing. Can you find V on which it will be surjective? So where I do it?
um,
Can I do here? Let me make a box here. Can I write down here?
yeah, it's fine.
Okay. So can so find V on which F is I mean okay. Find V for which F is surjective. Okay. Or you can say yeah.
Yeah,
Can you try this please? So solution. Yeah. So you take any Y from B, right?
yeah.
Yeah. So what
So
how
I'm
you do?
taking anyone.
Yes. Y from B. We take those elements, in codomain for which it has preimage in the set A. Okay.
Yeah,
Let me repeat. We took those elements. We will take those elements from the second set for which you know it has preimage. Got it?
yeah,
Okay. How you do this? This is very difficult. I mean, but if you write the expression, mathematical expression, every step properly, it will become easy. Okay. First, you have to make a target. We will find those element. We will took those element, or you know, if you take any element from that collection, there is a pre-image inside a set. Okay.
Oh,
Inside domain. I mean inside domain. Domain, you know what? All collection except two. Hmm.
yeah,
So
okay.
y belongs to B. Yes. Now fx equal to y. You consider. So what should we get? Yes. X plus
Okay,
3. Yes. Divided by x minus 2 equal to y. Solve for x. Solve for x. Okay.
okay.
If you solve, then what you get? X plus 3 will be what? Y into x minus 2, right?
Yeah,
Then x plus 3 equal to yx minus 2y. So let me do it here. So what should we get? We'll get here. We will solve for x. So what we get? X minus xy equal to what? Minus 2y minus 3. So what we get? We get x whole into 1 minus y equal to minus 2y minus 3. Right? Is this step okay?
yeah, it's okay.
This is a little bit I am taking time for this question, but if you understand this, you can solve the difficult question. Okay.
Okay.
Yeah. So this. Now tell me, can we took see look at this formula. We have x using y. What is the problem? Which value of y you cannot take here?
1.
1. So what will be the clever choice for B? B will be all number except 1. Got it?
Yeah.
So negative infinite. So let me write here. So B we can select all number except 1. So if you so domain is all number except 2, and if you take B all number except 1, then from domain to this set B, it will be a surjective map, also injective map. So it is a bijective map. Got it?
Yeah, got it.
Okay. So injectivity and surjectivity depends on, I mean, injectivity depends on domain, I mean, in the first set. Surjectivity depends on the codomain, I mean, exactly domain and codomain. Okay. Let me go to the next concept, composition of function. Should I start composition of function?
How long do you think we will
I
take
think
for
10 minutes, 10 minutes.
10 minutes?
Yeah.
Okay, maybe we can leave it for tomorrow then. Or maybe can you do only a video for me and send it on WhatsApp?
Okay. I will do that. Composition of
Only
function and
for composition. Only for composition. Then tomorrow, 6 your time if you can.
6, I don't know. I can wake up, and 7 will be better.
Okay, 7 is fine also.
All right. 7 is okay. Good. Okay. Okay. So I think we stop here, right?
Yeah, we stop
Did
here.
you
So just,
understand? Yeah. Please.
yeah, just if you send me the composition so we don't have to do it tomorrow. And tomorrow directly we start with the homework.
Oh, all right. Did you understood the homework solution that I send you?
Yeah, mostly I understood, but I need to like, I don't think I will be able to solve on my own. So I want to like go over with you how you did the steps so I can, if I get similar question in exam, I will know how to start it by myself.
Okay. Okay. Basically, this course is abstract math. Called, you start by saying that it is abstract. It is called abstract mathematics. I mean, whatever you have done so far, calculus, linear algebra, those you can generalize. So we need a language. That language is basically set theory. Okay. So that's why, you know, all the expression, all the formula can comes in, your when you writing the set theory. That's why a little bit challenging. I mean, if you, I mean, it's okay if you good with the function, you can get comfortable. Okay, like that. Okay,
Okay.
fine. Okay, see you then tomorrow.
Thank you so much, sir. I will talk to you tomorrow morning then,
Okay,
yeah.
thank you. All right.